Be very careful. High voltage inside. If you don't know what you're doing, don't go in there. If you aren't familiar and comfortable with electronics, don't go in there. You have been warned. I'm not going to be held responsible for people killing themselves. Hello everybody, and welcome to My Man the Maker. Today we're going to take a quick look at this wine cooler that was given to me by somebody moving away from Hong Kong because it doesn't work and they don't have time to fix it anymore. But they have been in there. They pulled out the PCB. This is basically power and logic board. So this is what you could charitably call a mid-repair machine, and I don't know whether it powers up, doesn't power up, nothing. So the very first thing I'm going to do is put it back together and try and power it up and see if we get any kind of display at all, or whether the machine is well and truly dead, because it's currently in an unknown state. So the very first thing to do would in my mind at least, is to familiarize myself with the machine and also get to know what its fault condition is. That little beep is just my meter turning itself off. So yeah, here we go. We're gonna just take these screws out, get the back off this thing, and then talk about the machine once I've got it opened up. Well, here's the back of the unit. This is a Vinvautz model VZ18BN wine cooler. I figure I'll use it for red wine if I can't get the cooling unit working immediately. We don't cool our reds in this home, but we do cool the whites. I doubt we'll ever have 18 bottles of white wine, so who knows. Mostly it's just the repair challenge I'm after here. So how do you take one of these things apart? Well, the first thing you should know is that this is a generic wine cooler. It's sold under a bunch of different brands. Emerson. It's sold under, what else did I see out there? I saw a bunch of sort of mid-market, low-end brands. By low-end, I just mean mass market. I'm not trying to disrespect mid-market or low, or imply somehow that low-end is low quality. It's just low price, and you get what you pay for. So in this case, it's a generic wine cooler designed for 18 bottles. It's been marketed successfully to a bunch of lesser brands, and if you want to get a super high-end wine cooler, then you would probably go with a specialized specialty manufacturer that only does this. But essentially this is just a little tiny thermoelectric cooler and storage unit for wine. So it's not, you know, super technically challenging. You just need a thermostat and a little microcontroller and some power management, and that's basically it. So these things tend to get manufactured for a certain price point, and what happens is they make compromises in terms of the quality of the components. So my guess is most likely, like a little simple component on this board, which costs $50 US to replace, has failed. Likely candidates for board failure, just so you know, are these very large capacitors. Those are almost certainly smoothing capacitors used in the power supply. The so-called high-end, or you could call it the hot end. I call it the lethal end because this is where high voltage is. High voltage here, low voltage generally speaking there, and that's indicated by this clear separation between the components on the board. So there's, instead of an air gap, which would have been preferred, there's a physical space of about a centimeter between the high voltage portion of the PCB/logic board and the low end, which is what I would call the TTL side. So these two capacitors are almost certainly used in the smoothing of the incoming alternating current, which in this country is 220 volts. And that means that this thing is going to get kicked up to, you know, at least 220, 300 volts on this side, whereas over on this side, I'd be surprised if it's greater than 12 volts because it's running low, very low current stuff. I mean, this whole thing is rated for 0.5 amp. That's like 1/3 of a hairdryer in terms of the ability to remove heat. It's got 3 components, transistors that produce a lot of heat. That's why there's that big heat sink. This heat sink also serves as a barrier between the high voltage side and the low voltage side. And then we got a couple more transistors sitting on heat sinks. So what's going to fail? What's going to fail is this one, this one, this one, this one, and maybe the little ones on the inside scattered here and there and everywhere. There's a fuse. The fuse is right there. I've tested the fuse. Fuse is good. That would be the first thing you should check, is a fuse. Coils tend not to go. There's a relay. This relay might have gone bad. So those are the sort of things you look for. But I mean, it's very difficult to troubleshoot this board, seeing as it's already been removed. So the easiest thing for me to do is simply put it back in, plug this unit in, and see how it behaves. Taking it apart is pretty simple. You got a screw here, a screw here, a screw here, and then you march up the perimeter of the case. Now I've seen people take this unit apart by undoing these perimeter screws here and then bending the case backwards. I don't think that's necessary. I think they just didn't notice these 3 screws on the bottom. So I'm pointing that out so you don't bend the back of your wine cooler when you do decide to, if you ever decide to open it up. Be very careful. High voltage inside. If you don't know what you're doing, don't go in there. If you aren't familiar and comfortable with electronics, don't go in there. You have been warned. I'm not going to be held responsible for people killing themselves by reaching into a high voltage situation and not knowing about basic safety in terms of electronics. If you don't know what you're doing, take a course, get certified, go to school. That's what I did. Anyways, so here we go. You can see there's a mess of loose wires up here. We got the sticker, which tells us a few things. We got a model number, takes 220 volts, 70 watts, 0.5 amp. Volume's 48 liters. That's nice to know in case you want a fridge. It weighs, let's see, 32 pounds, 16 kg, thereabouts. Protection type is I, and it consumes blah blah blah, 1 kilowatt hour for every 24 hours. So it's really a low voltage device. And then you've got a basic schematic sitting here to give you some kind of basic idea of what's going on. Then there's warning labels, and this looks like a filter. I don't know if it's ever been cleaned. Doesn't look it. So we'll clean. We'll probably vacuum out the inside or blow it out, because I've got a compressor now. You blow out the inside of this thing. So the next thing to do is just take these screws out and get the back off, which I'm going to do now. And let's have a look at the guts once I've done that. Well, here's the machine open. As you can see, there's a couple of 4 stereo units there. Those are almost certainly 12 volt fans. Then we have the heat exchanger, which uses a principle called a Peltier phenomena, technique, effect. Basically, you run current through a plate and it cools down. So it's a good, very, very quiet cooling technology, but it doesn't cool a lot, and it doesn't cool fast like aircon. And then you have, here's a power connector. So this is the kill you power, and it comes in, there's a ground. So that's going to have 220 volts between, alternating current between those leads. Then it goes into the board, which should be here, taken out. And from the low voltage side, you get a bunch of connectors here, and these are looking like maybe a thermostat. A thermostat, maybe a fan connector, maybe another fan connector. Usually the convention, at least in some other places I've seen, is this is a 12 volt connector and this is a 5 volt connector, but we'll see. And then we got a couple of blade type adapters here. One's red, one's black, so there's going to be a positive and a negative there. And then a 3-pin connector, which is probably for the display. So what we need to figure out is, I know there's only one of these, there's only two of these, but there are three 2-pin connectors, and I don't know which goes where, so I'm probably going to have to look online to see one where the board is plugged in, just to make sure I don't plug the wrong thing in the wrong place, because these could very easily go anywhere. Plug the wrong thing in, you probably get magic smoke. So what I'm going to do now is, the board's clean and the top is clean, but this part here is not clean. So I think what I might do is I might just take it outside for a quick treatment of a little TLC with the compressor, just so I don't get my hands all dirty while I'm working on this, and I don't want the place I'm working in to get dirty either. So that's the next thing. I'm just going to clean it up with some forced air, and then we will mount the board and plug in what we can plug in, which is the power and the display, and turn it on and see what happens. And then if nothing happens, I have more information than I do now. Here we go. Now that the machine's been blown out with compressed air, it's a lot cleaner and more pleasant to work with. We're going to have to do something with this. I think this is probably a drip tray for condensation. We'll deal with that later. For now, it's the challenge of the wires. Considering the fans are using red and black, I'm guessing that's a fan wire. There we go. That's probably a fan wire, so that's easy enough to figure out. And then we have these two, and these two are a bit of a mystery. We've got a yellow and black and a black and black. Typically, yellow and black is polarized and black is not. So I'm guessing this might be for a thermal resistor. I think I know what connector that is. And this is for a different connector. So let's take a look at the board and see what we can see. On the board we have, use a screwdriver, I'll maybe use a probe to point stuff out. Here we have a resistor. I think that's where the black and black goes. Here's the 3-prong connector for the display, that's easy enough. Here is fan 2, and here is, I can't read it. So my guess is one of these two is, well, this is the fan, this is the thermo, I think probably what we call a thermocouple or a thermal resistor, which makes this the yellow and black, black and red, black and black, 3-color pin, and the 2 blade, which are polarized. We got a minus there, and we got a plus right. Let's see if I can get the camera on it. There, on P1.
a little hard to see because of the shadow. But there's a plus there, believe me. Besides, if there's a minus here, there must be a plus there. That's the way, kind of way it goes. So I'm just going to look up these connectors to make sure, but I'm guessing this is red and black, black and yellow, 3-pinner, and black and black. So I'll get right back to you. Of course, yeah, and the power connector for the 220 is very distinctive, so that's an easy one to figure out. So I'm just going to mount up the board next and wire in the stuff that I know I can do. Like I said, the display and the power. Plug it in and see what happens.
I hope you liked this video. If you did, please consider subscribing, giving me a like, and leaving me a comment. I really enjoy making these videos, and I want to know from you how I can make them better. The whole point of these videos is to demonstrate that if I can do something, you can do it too. Well, that's it for now. So long, and remember, keep making.